All right, guys, let's take a look at number one as a type of sample here. So we're going to use the balanced chemical equations given to calculate the mass of a gas. Assume all gases are under the same conditions of temperature and pressure. All right, so the combustion reaction, right? Combustion, because I see a hydrocarbon reacting with oxygen, so that's going to be a combustion reaction. This happens to be propane, and no, you don't have to have that memorized. I tell you what it is right here. But the reaction is represented by the following equation. Now, one thing I can do real quick is I can look at the coefficients on the chemical equation and I can double check that it's balanced, right? That is super important that you begin by having a balanced chemical equation. There will be times when you are given a chemical equation and it's not balanced. You cannot move forward in the problem and expect to get it right until you balance it. Okay, so here it happens to already be balanced. So, number one, if 120 grams of propane, which is the C3H8, is burned in excess oxygen, which is what it means to combust, how many grams of water vapor are formed? Now, last time we met, we talked about conversions using moles and grams, right? And so the conversion factor that we used was called molar mass. You guys remember, that's how many grams of a substance there are in 1 mole of a substance. In this situation, we are doing that 2 times, okay? Because you'll notice that I'm given information in grams, and the question is asking for information in grams. Now, there is no magical number that allows you to convert from grams of one substance into grams of another substance. Doesn't exist. But what I can do is I can convert from grams of substance A, I can convert that into moles of substance A, and I can do a mole to mole conversion, convert into moles of B, and then once I'm actually talking about moles of B, then I can convert into grams of B. Now, the way I've drawn this on the page so far, each of these things that are arrows are representing conversion factors. So to set up this calculation, I'm actually going to have to do 3 different conversion factors. So let's get it going. So 120 grams C3H8. I'm going to convert out of grams of C3H8 into moles of C3H8. That's the first conversion factor. That's going to get me into moles of the first substance. Now, do you guys see how this works? Grams of the C3H8 will cancel out, and at this point, the only unit left in the entire calculation will be moles of the first substance, the moles of the propane. See how that worked? Okay? So that's the first step done. But then I need to convert out of moles of the A, which is the propane, and convert into moles of B, which in this case is the water vapor. So moles of C3H8 on the bottom, because that's what I want to cancel, and moles of H2O on the top. That's the substance B. That's what I want to convert into. Again, notice there's a moles of propane on the top and a moles of propane on the bottom. That is what allows me to cancel, get rid of them. Again, after this conversion factor, which is the second arrow, the only unit I have left is moles of the second substance, the moles of B. But I'm not done yet. I need one more conversion factor that will allow me to convert from moles of B to grams of B. Again, in context, moles of B is moles of H2O, and grams of B is grams of H2O. Again, this might be a little bit repetitive, but notice how I have a moles of H2O on the top and a moles of H2O on the bottom. They get to cancel out. And so after all of this, the only unit I have left is grams of H2O. But look, isn't that what the question's asking for? Yes, I'm there. So whatever I get in terms of a number here is going to be a grams of H2O. But here's the question. What numbers do I plug in on these different conversion factors to actually do my calculation? First off, I need the molar mass of C3H8. So the number of grams for 1 mole of C3H8. Make it easy on yourself, use a calculator. Okay? What's the mass of carbon? I look at the periodic table, I see it's 12.01. How many carbons are there? 3. So I'll multiply that by 3. Then I'm going to add that to how much hydrogen's there. So again, I look at the periodic table. And that hydrogen's going to have a mass of 1.01. How many hydrogens are there? Multiply that by 8. And so that right there is going to be the molar mass of propane. And that, in fact, is the number they put right there. I'll do one more over here for water. Do the exact same thing. I see there's hydrogens. There's 2 of them. Again, that 1.01, I don't have that memorized. I'm looking at the periodic table. You need to have a periodic table pulled up and looking at it the entire time. The formula tells me that there's 2 of them, so I multiplied it by 2. Then I'm going to add that to however many oxygens there are. There happens to be 1. So 1 mole of H2O has a mass of 18.01. So I have the molar masses done, but here, this isn't a mass. The term mass is not in here. This is a mole to mole ratio. And this part right here, it's the last thing you need to do before you start, doing your final calculator work. This is why you need a balanced chemical equation. Okay? Do you guys see the propane up here? What's the coefficient in front of the propane? You guys see it? What's the coefficient that's out in front there? 1. So, I put a 1 in front of moles of propane. On the top here, I want moles of water. So I find water up here. What's the coefficient out in front of water? 4. So, reading this equation, I see that propane and water occur at a 1 to 4 ratio. And so I'm going to take that into account when I do my calculation, and I do it in this way. Water occurs at a 4 to 1 ratio with propane. Now I'm ready to do my final calculator work. Now, I insist that you show your work in this way. I insist upon it. In fact, I will not give you points on things if you do not do it this way. Teacher, I figured out a shortcut that works. I'm not interested. Do it this way. Because this is the way that will work in every scenario. Okay? You might find a shortcut that works for this kind of entry-level stoichiometry, but that doesn't mean that your shortcut's going to work for everything. And so I don't want you practicing an approach that won't work on everything. This will work on everything. So, now I'm ready for my calculator work. Now, all the numbers that are numerators get multiplied by all the numbers that are, by each other, and then divided by the numbers that are on bottom. So check this out. 120 multiplied by 1, multiplied by 4, multiplied by 18.01, divided by 4.1, divided by 1, divided by 1. Boom. Now, you might be watching this thinking, well, these are ones, and so they're not going to change the overall value. Do I have to kick them into the calculator when I'm doing this calculation? Okay, for this specific one, no, because dividing by 1 doesn't do anything. Multiplying by 1 doesn't do anything. But in the near future, these won't always be ones. There will be situations in which you'll be multiplying by things that aren't 1. And so I want you to be in the habit of including everything. Okay?